Hi everyone, I'm Miss H, and today we're going to be looking at momentum. By the end of this video, you should be able to define momentum and calculate it. So let's get started with the definition. Momentum is defined as mass in motion. This means that it depends on both how fast it's going and how much of it there is. So the greater the mass, or the greater the velocity, the greater that the momentum will be. When we use momentum in a formula, we use the variable of the Greek letter rho to represent it. Rho looks very similar to a lowercase p. The formula for momentum is mass times velocity. When we put this into our triangle, we have to make sure to keep mass and velocity multiplied together. So they're going to go in the bottom of the triangle. If I cover up my momentum, I get mass times velocity, which is my original formula. If I can get my original formula back, I know that I put it in my triangle correctly. If I cover up my mass, I have momentum divided by velocity. And if I cover up my velocity, I have momentum divided by mass. It's very easy to forget that m represents mass, not momentum. So be careful when you're looking at your variables. Since velocity is a vector and can be either positive or negative, momentum can also be either positive or negative and is also considered to be a vector. Remember that a negative value means that it's moving in a negative direction, such as west, south, down, or left. The unit for momentum is simply the unit for mass squished together with the unit for velocity, so it's kilogram meter per second. Again, you have to be careful and watch the placement of your multiplication and division symbols because that changes what the unit means. So let's take a look at some examples. In this first example, we have a 2 kilogram steel ball bearing that is rolling at a rate of 2.8 meters per second, and we want to know what the momentum of this ball bearing is. So the first step when I solve a problem is to identify. So I have 2 kilograms, which is a mass. I have 2.8 meters per second, which is a velocity, and I'm asked to solve for momentum. If I look at my momentum formula, I have momentum is mass times velocity. So that was my second step, writing the formula. My third step is to fill in those numbers. So 2 kilograms times 2.8 meters per second will give me my last step, solve. Momentum equals 5.6 kilogram meter per second. Notice that none of the variables there can cancel out. Let's look at another example. A marble is rolling with the velocity of 1.5 meters per second and 0.10 kilogram meter per second of momentum. What is its mass? So I'm going to start by identifying my velocity, my momentum, and what I'm being asked to solve for, my mass. So if I put my formula into my triangle, I see that if I want to solve for mass, I have momentum divided by velocity. So I have 0.10 kilogram meter per second over 1.5 meters per second. These units are going to cancel out, and that's going to leave me with a mass of 0.07 kilograms, which, since we're dealing with the marble, we'd expect to get a really small number. Let's take a look at one more example. What is the velocity of a 0.14 kilogram baseball with 6.2 kilogram meter per second of momentum? So again, I'm going to start by identifying. They want me to solve for velocity. They've given me a mass, and they've given me a momentum. So if I put this into my triangle, Cross out my v, I end up with velocity is momentum over mass. So that's 6.2 kilogram meter per second over 0.14 kilograms. So my kilograms are going to cancel out, and I'm going to get 44.3 meters per second for my velocity. Now I'm going to put up some examples or some practice. Okay, so I'm going to put up some practice problems, and I want you to pause the video now and see if you can come up with the right answer to this first question. What is the momentum of a 0.2 kilogram bird traveling at 9 meters per second? So go ahead and hit pause, and once you think you have the answer, go ahead and hit play on the video again. So hopefully you did 9 times 0.2 and came up with 1.8 kilogram meter per second. The second practice problem, what is the mass of a football player with 1,000 kilogram meter per second of momentum traveling at 10 meters per second? Again, go ahead and pause the video, and once you think you have the right answer, hit the play button. Hopefully you did 1,000 kilogram meter per second divided by 10 meters per second to get a mass of 100 kilograms. The last practice problem, how fast is a 60 kilogram skier with 1,200 kilogram meter per second of momentum? Again, go ahead and pause the video and see if you can come up with the right answer. Hopefully you did 1,200 kilogram meter per second divided by 60 kilograms to get 20 meters per second. If these are still giving you a hard time, look for some extra practice problems. The last thing we need to look at with momentum is the law of conservation of momentum. The law of conservation of momentum says, in an isolated system, the total amount of momentum after a collision will be the same as the total amount of momentum before the collision occurred. In other words, when you don't have anything else to take into account, when object A hits object B, the total amount of momentum won't change. So if I have a shopping cart here, we're going to call this guy A, and a shopping cart here, I'm going to call this one B. Okay? B is standing still, so B has 0 kilogram meter per second of momentum. Let's say that A has 40 kilogram meter per second of momentum, and A is going to hit B. After A has hit B, they're now both going to be moving forward with 20 kilogram meter per second of momentum each, because the total amount of momentum had to be conserved, and 40 plus 0 divided by 2 gives me 20 each. So when you're working on a lot of conservation of momentum problems, the important thing to remember is that the amount that you start with and the amount that you end with have to be the same. So hopefully now you can tell people that momentum is mass in motion, that the more mass that an object has, or the faster that it's moving, the greater its momentum will be. And now you should be able to calculate momentum using the momentum formula of momentum equals mass times velocity. You should also be able to state that the law of conservation of momentum says that the amount of momentum you have before and after a collision will be the same. Good luck, everybody.